Hello everyone, welcome to the Computer Networks lecture series. In this particular session, we'll study about the digital transmission. So the very first topic is digital to digital conversion. So what exactly is this? So we have various line coding schemes. So they do this digital to digital conversion. So what is line coding? Line coding is the process of converting digital data to digital signals. So we have data in our systems, in our any of the machines. We want to transfer the data from one host to another host. So if the data is in a digital format, we need to convert it to digital signals before transmitting. So this as we can see, we have encoder and decoder. So here this is the digital data. This digital data is coming from a host, so this data has to be converted to signals and then it is sent to the other host. So this is how it converts the digital data to digital signal. So this is the conversion of data to signal, which is the line coding scheme. Then at the receiving end, we again convert the signal back to data, which is done by the decoder. So this is the process. There is a line coding of the process of converting digital data to digital signal. That is the digital to digital conversion. Now there are various line coding schemes. As we can see, they are of various categories. Like we have unipolar, polar, bipolar, multi-level and multi-transition. And in unipolar we have NRZ. NRZ means non-return to zero. In polar also we have NRZ, that is non-return to zero. RZ, return to zero. Biphase. In bipolar we have AMI, pseudo ternary, and in multi-level we have the 2B/1Q and so on, and in multi-transition we have MLT3. So these are the various schemes. We'll study one by them one after the other. So let us see what is the meaning of unipolar scheme. So in unipolar we have only one, that is non-return to zero. Now why it is called as unipolar? Because we only use one voltage level. So we use positive voltage to represent 1 and 0 voltage to represent 0. So here it is only having one polarity. It can be positive, it can be only negative, it can be only positive. In our case we are only using the positive voltage. So suppose we have this this is the data. We want to represent this 1 1 0 1 0 0 in the form of signal. So we use this scheme. Okay, so positive voltage means 1 and 0 voltage means 0. So here we only have single polarity, that is only we are using the positive voltage. We are not using the negative voltage, only positive we use. Therefore it is called as unipolar. Now let us see the polar scheme. So in polar scheme we use both the sides of the time axis. This is, we use positive as well as negative voltage. So in one of the schemes we can have positive voltage for 0 and 1 for the negative voltage. So if we want to represent 0 bit, we represent the positive voltage. If we want to represent 1 data bit, we represent it by the negative signal. So these are the various types of polar scheme we will be discussing. One is the NRZ, that is non-return to zero. Then we have return to zero, and we have the biphase. So let us study the polar NRZ. So polar NRZ is of two types, NRZL and NRZI. NRZ means non-return to zero, L means level, and NRZI means non-return to zero invert. So let us see first NRZL. So in this case, positive voltage means 1 and negative voltage means 0. Okay. So in this case, suppose we have the data 1 0 1 0 0 1. So this is the positive voltage is 1, negative is 0, positive is 1, negative is 0 0, then finally we have 1. So as we can see, both the polarities are used. We can even have the swapping, like we can represent positive voltage as 0 and negative voltage as 1 as we like. So this is one of the type of representation. The only thing is that we are using two voltage levels, negative and positive both are used. So one level, so why it is called as level? Because one level shows a particular bit, another level shows another bit. Now let us see NRZI, invert. So in this case, if the next bit is 1, there is no transition. If the next bit is 0, there is a transition. Let us see how it works. We use the same bit 1 0 1 0 0 1. So now for 1 we start with, let us say, positive voltage. Now next bit is 0, so there will be a transition. transition means what? The positive polarity converts to negative polarity, so it goes to negative. Now the next bit is 1. Okay, so there is no change, in the polarity. Okay, now next bit is 0, so there will be a change, there will be a transition, so there is a transition. Then again next bit is 0, so again there will be a transition. Okay, now next bit is 1, there is no transition, the polarity is same as it was in the previous case. So this is how NRZI works. Now we have, in case of polar RZ, the third is the RZ, it is called as return to 0. Now here positive voltage means 1 and negative voltage means 0. Let us see how it is different from the previous two schemes. So here for 1 the voltage starts from positive and returns to 0. Okay, and for negative, for 0 voltage, the signal starts from the negative side. Okay, now as we can see, the green arrows, they show that the signal is returning to 0 in the middle of the bit. Okay, so that is why it is called as RZ. So return to 0 means what? The signal returns to 0 before the completion of the bits. So for 1 it starts from a positive voltage and comes to 0 in the middle of the bit. For 0 it starts from the negative voltage and comes to 0 at the middle of the bit. So this is the scheme we have, that is why it is called as RZ, is the return to 0. Then for polar biphase we have two schemes, one is Manchester, other is differential Manchester. So how Manchester works? So for positive voltage we have 1, negative we have 0. So this Manchester, we can say it is the combination of NRZ, L as well as RZ. So here the same, we are using the same bits, 1 0 1 0 0 1. So here we can see for 1 it starts from a positive voltage and goes to the negative voltage, and for 0 it starts from negative voltage and goes to the positive voltage, and there is a transition at the middle of the bit. Okay, so for 1, as we can see, ZZ we are getting, and for 0 we are getting SS. That is what we can see. So for 1 we have the signal starts from the positive side and goes to the negative side, and for 0 it starts from the negative and goes to the positive side. So this is the Manchester. Next is the differential Manchester. So here for 1 there is no transition, and for 0 there is a transition. Okay, so here for 1 we start here, and for 0 there is a transition. Okay, so wherever 0 comes next, there is a transition. As we can see with this, all these green arrows, they show there is a transition. Okay, it goes from negative to the positive polarity whenever the next bit is 0, and the red arrow shows that there is no transition because the next bit is 1. So this is we can say the combination of NRZI with RZ. Next we have a bipolar scheme. In bipolar scheme, 3 voltage levels are used, positive, negative as well as 0. So the voltage level for one of the data will be 0, and the voltage level for the other, it will alternate between positive and negative. So these are the two bipolar schemes, that is AMI, alternate mark inversion, and pseudo ternary. These are the two bipolar schemes we'll be studying. So let us see what is AMI. In AMI, if the next bit is 1, the voltage will actually alternate between positive and negative voltage. If it is 0, it is 0. So let us take the same bits, 1 0 1 0 0 1. So as we can see here, how there is a transition. So you can see the red arrows and we have the blue arrows. So red arrows, as we can see, there are the one data bit 1 comes 3 times. So for the first one we get positive, for the second one it becomes negative, for the third one it again becomes positive. So for every next one, it actually alternates from positive to negative voltage. As you can see, this arrow marks, and the blue one, blue lines, the blue arrow, they show 0. So 0 is always 0. Okay, for 1 the voltage alternates between negative and positive for the every next bit. So suppose after this, after the third one, if there had been one more one, it would become again negative, and for 0 it remains 0. Now next is pseudo ternary. Only difference is whatever was happening for 1, it happens for 0, and whatever was happening for 0, it is happening for 1. So here we have this. Okay, now you can make out. Okay, so as you can see, there are 3 arrows. For the red arrows, they show 0, and there is a transition. There are 3 zeros, and this signal transits 3 times So for first 0 it is positive, second 0 it becomes negative, for the third it becomes again positive, but for 1 it is always 0. Okay. Now next comes the block coding. Okay. So what does block coding do? So block coding, it changes a block of m bits into a block of n number of bits. So in this case n would be always greater than m. So our initial code data will be of m bits and final data will be of n bits. So our data will be of less bits and the final data will be of more number of bits. So as we can see here, we have a block of m bits, it gets converted to n bits. Now this extra bits, so because n number of bits, they are more as compared to m number of bits, so whatever the extra bit, they provide some redundancy. They are used for synchronization and they are also used for error detection. Let us say this 4B 5B scheme. So in 4B 5B scheme, our initial data will be of 4 and the final data converted will be of 5 bits. So the data is converted into blocks of, so how this scheme works? So whatever data we are having, this data, let us say this is our data, so we convert, we actually make blocks of 4 bits. So this is our original data and we actually divide this data into a block of 4 bits and then we convert this into a data of 5 bits. So this is the conversion. So every block of 4 bit is converted to 5 bit block. So with 4 bits we can make 16 combinations. These are the various 16 combinations, and with 5 bits we can make 32 combinations. So these are the 32 combinations. So if we, in this case, if we make the mapping, on the left side we have 16 columns, so 16 rows. On the left side we have 16 rows, on the right side we have 32. So if we make the mapping 16 1-to-1 mapping, then on the right side 16 rows will be left without any combination. So what we do with this, so this, suppose this is the data and this is the code. So for this data, what we do is the in the previous case, as we saw, the 4 bit, with 4 bit we make 16 combination and with 5 bit we make 32 combinations. So out of the 32 we only use the 16 rows. Okay, so whenever we want to send the first row, that is if the data is 0 0 0 0, then we convert it to 0 0 0 1 1. So this is the mapping. So the data of 4 bit is converted to 5 bit. So we want to send this 4 bit data, we convert it to this 5 bit data using the particular scheme. Now what do we do with this remaining 16? Okay, remaining 16 rows. Okay, now this row, they can be used to send some signal, like if the sender sends all the 5 bits at 0 as 0, it makes it is quiet, it is not sending anything. Then if the bits is 0 0 0 1, it is idle, it is not it is not quiet, it is idle, that is it is ready to send or receive data. Then 0 0 1 0, it means halt. So this various signals can be sent by the remaining bits. Okay, now next topic is analog to digital conversion. So there are various applications where we need to convert our data from analog to digital. So one of the way is using the pulse code modulation. So in pulse code modulation, this is our original analog signal. It passes through a PCM encoder, pulse code modulation encoder, and the first component of this is the sampling. The input signal is sampled, then output of sampling is given to quantizing, then output of quantizing is given to encoding, and finally we get this digital data. So here we see that this analog signal is converted to digital data using this PCM encoder. Let us now understand the working of each and every component of PCM encoder. The first operation is sampling. So what happens in case of sampling? This analog signal is passed through a sampling circuit, which is called a sample and hold circuit. Now this sample and hold circuit, it actually chops the signal. Okay, so it just breaks the signal into number of we can say waves. Okay, so as we can see on the right side, this signal is actually broken. Okay, then this signal, okay, is given to the quantizing circuit, the quantizer. Now what the quantizer does, quantizer actually, it we can say adjusts this value to a proper whole number. Okay, so we know, like if we know this encoding, so if we convert this numbers from 0 to 7 to binary, so the code for 0 is 0 0 0, the code for 1 is 0 0 1, for 2 is 010 and so on, and the code for 7 is 111. So when we are breaking this signal, when the sampling circuit it breaks the signal, it may happen that we are getting like 1 volt. We know the code for 1, but we don't know the code for 1.5. So quantizer it adjusts, okay, it quantizes, means it is rounding the number. So if this broken signal represents 2.5, we don't know the code for 2.5, it adjusts it sends it to 3, it makes it 3. Okay, so that is what quantizing does. It actually rounds the values which were given by the sampling circuit. Okay, then finally the encoder circuit. What the encoder does, it converts this particular data, like 3, the code for 3, it gets the code for 3. So 3 in binary 011, then 5 is 101, 6 is 110 and so on. So this is done by the encoder. Encoder converts this particular data into the binary one. So this becomes actually binary, means the digital data. So this is how we get this output. Next, we have the various transmission modes. So data, when it is transmitted, it can be transmitted using various modes. So we can classify them into 2, serial as well as parallel. So data transmission, it can be serial, it can be parallel. And again, serial can be also classified into 3 more types: synchronous, asynchronous and isochronous. So let us see first the parallel transmission. So in case of parallel transmission, we have sender and receiver, okay, and they are connected, like in this case they are connected through 8 wires. Okay, in this case we have 8, actually the interface supports 8 wire together. So this, like suppose if you want to send the data, we can send in this case 8 bits at a time. Okay, so all the 8 bits travel at the same time. Okay, now what are the various advantages of parallel transmission? Of course, high speed, more data can be sent at a time, and of course it is efficient transmission. We use the so if the speed of sender is very fast, we can make an efficient use of the sender and the receiver. Then there is reduced latency, so there is no delay. The delay means that the delay is very less. If we compare this with serial communication, the delay in this case will be less as compared to serial transmission. Now the disadvantage is the cost. Of course, we require more amount of wire, so the interface is also it becomes expensive. Then of course this circuit becomes too much complex, and this particular transmission mode, parallel, it cannot be used for long distances. It can be only used for limited distances. So these are the disadvantages. Now let us come to the serial transmission. First is the asynchronous transmission. So in this serial transmission, the sender and receiver, they are only connected by a single wire, a single transmission we can say channel. So here the data by the sender is sent in terms of bytes, we can say. So here we can see this the data starts with the start bit, and it terminates with the stop bit. So what the sender does, it arranges the data into frames. So this is one frame. So it starts with a start bit and it ends with a stop bit. So the data is sent in this particular format only. So this is how the data is sent. So receiver knows when the data is coming and when the data gets terminated. So this is asynchronous, is of course very slow transmission mode. Then next is the synchronous transmission. In case of synchronous transmission, there is no start, there is no stop bit. The data, it just goes in bulk form. Okay, so this is how the data goes into the bulk form to the receiver. So it is the responsibility of the receiver to receive the data properly. Then the final is the isochronous transmission. Now in case of isochronous transmission, this particular transmission is used for real-time audio video. Okay, like we are watching a cricket match, maybe live transmission is going on, or we are having a conversation or telephonic conversation with this is an example of real-time communication. So in this case, the data rate should be fixed and it should be uninterrupted. So for such transmission, we use this isochronous. So that this isochronous transmission, it supports fixed rate data transmission. So that's all for this particular session. Thanks for watching. Do join for our next video.